Walter Levin, a professor from MIT, aside from a fantastic physicist, he has another amazing talent. He's able to draw dotted line on blackboard with unbelievable speed and crazy precision, and it makes a pretty cool noise too. However, how to realize it? We want to explore the parameters that affect the movement between the chalk and the board, and in which conditions the dotted line can appear. After some practice, we realize the dotted line by hand.
As we can see, those traces on the blackboard seems to have its own rules, but why the interval becomes larger and larger by time, and why one short line is consisted by two parts, we will explain it later. In order to explore the rules of this point, we made an experiment under a high-speed camera and we analyzed the result with imagery. We put a ruler beside the trace for scale so we can know the exact interval between 2 points.
In theory, to simplify our problem, we started with a 2D physical model and make some simplification, like in the finger. It is a model from an article named Could Chalk Hopping Be Caused by Reversed Chatter, which was published in American Society of Mechanical Engineers in 2019. In this model, we assume that the chalk has a mass m and a length 2r. The external force Sx and Sy was applied in the mass center or in the middle of the chalk. We analyze the force on the contacted point P and deduce three equations in x, y, and rotation direction shown in the blue rectangle. In certain conditions, it causes a phenomenon called reversed chatter. The value we measured in the experiment satisfies very much the condition. So, we can say, under constant external force, there is a reverse chatter in y displacement and normal velocity and tangential velocity. The theoretical result is consistent with the trees observed in the experiment. A good model? No. And for the second question, we think that is because the chart is not ideally aligned but has a limited width, which causes in fact two contact points.
In order to study the frequency and amplitude of blackboard vibration, we use a pico system to collect data and use a computer to record the data. We did this experiment on the edge of the blackboard because our electrodes are not perfectly flat. The first factor we considered is the length of the chalk, and here is the result of the length of the chalk equals to 8 centimeters. As we can see, here is the result of the length of the chalk equals to 3.4 centimeters. As we can see, the frequency is much more higher than the length of the chalk equals to 8 centimeters. We have made a lot of experiments in different velocity, and we can find with the result that even at low velocity the chatter happens, but with low frequency, and the length affects more greatly the frequency than controlling the force. Finally, we build a system with a fixed radius of rotation for constant velocity. We can also place weight on the chalk to simulate the different force we apply to the chalk. Here is the example when the voltage of the motor is 10 volt. And here is the example when the voltage of the motor is 15 volt. And last here is the example when the voltage of the motor is 31 volts. As we can see, the higher the voltage, the faster the speed of the motor and the faster the vibration frequency of the chalk.